this is going to be quite a full panel. We're going to have 6 speakers on it. And the term AI, and to give a little bit of an introduction, has become the buzzword recently in industry as well as in media. There's hardly any startup pitch that doesn't sprinkle the term AI into their pitch, and there's hardly a magazine that didn't at least have one cover story on AI yet. But what often happens with buzzwords is that they become conflated to mean everything and nothing at once. For example, the AI term mostly used in startup pitches refers to advanced computer science, to the ability to train machines to do some specific task really well. But rather than talking about this narrow set of AI, today we want to talk about the original goal of AI, about artificial general intelligence, with the goal to create an agent that can do a broad set of tasks as good as humans, or perhaps even better. And while the media often addresses artificial general intelligence, it doesn't always do that in a way that's very helpful for reasoned debate. And that's problematic, because the topic of AGI is so important. Most future-minded organizations rate artificial general intelligence in the top 3, if not as the single most important issue to work on today. So it's time for a reasoned debate on the state of the art and the future of AI. Please participate by voting on Twitter. We're at Foresight Inst. Questions will be up soon. And please help me now welcome our panel. Steve Omohundro, Monica Anderson, Osh Agabi, Peter Voss, Michael Andregg, and our moderator, David Yanofsky.
Hello. So I'm David Yanofsky. I'm a reporter at Quartz. As you heard, our panel today is on artificial intelligence, and not just any narrow artificial intelligence like you might have heard with a Go playing computer or a chess playing computer, but general intelligence, being able to take on a multitude of tasks in the way that a human might. We're very early on in achieving artificial general intelligence, and we've already seen some of the risks, and we've seen and heard some of the risks, and we've seen and heard of some of the failures, whether that be computers that or machines that have bias, or machines that are unsafe, or machines that give nonsensical answers, even though they are completely confident in the output that they're returning. And then, of course, there are existential risks about ceding judgment to computers. So on this panel, we have Peter Voss, who is the head of AGI Innovations. We have Monica Anderson, Director of Research at Syntience, Osh Agabi, who is the CEO and founder of Koniku, Michael Andregg, at the end there, co-founder of Fathom Computer, and Steve Omohundro, the founder of the Center for Complex Systems and Research. We want to talk about why you should be dropping everything and getting into AI right now. So I think in your own words, we can start off with that, and your feelings on kind of the future of AI.
So I'll start. Really happy to be here. I think we're right on the verge of a major transformation. I think there's a tsunami coming at us that we can transform into great good, or there can be not so good outcomes. And that I don't actually believe that everybody should be working on AI, but I do believe everybody should be thinking about the kind of society that we want, because AI is going to transform every aspect of society. And I think that it's going to come in 3 waves. The one we're in right now is AI economy, a transformation of the current economy. McKinsey estimates that $50 trillion of value will be created by AI and robotics in the next 10 years. So that's massive. And so as systems are starting to work, you're seeing incredibly huge investment. Second one is AI military, which is just getting going, but every country on the planet is starting to develop AI soldiers. US is planning by 2025 to have more robot soldiers than human soldiers. Lots and lots of complex issues there. And then I think the third phase is what I'm calling the AI society, where these systems become of the same level of intelligence as humans. They became full-fledged citizens. We need a new legal system, we need a new justice system, we need new policing systems. We need basically an entirely new infrastructure to manage this. And it's probably coming in the next decade or so. And so that's where I think most people should be thinking at the moment.
So we take a completely different tack to AI. So we see a lot. So I'm a neuroscientist by training. So that's a bias. A lot of what we see today is data science. And it's very, very good data science. Fundamentally, we think cognition, there's a market for cognition and there's a need for cognition. The approach we have taken is actually taking biological neurons, so wetware, and merging that wetware, merging it with silicon technology. The advantage that biological systems bring is that they have sensory integration, they have incredible memory management, and they have intelligence built right into the same system. Now, I agree with the data science that we have, or commercial AI as it is today. It has a lot of potential. We've already seen the effects from the stock markets to image recognition and so on. But cognition, we still think it's a fair way away. And the system that is going to be able to achieve that is actually the merger of biological systems with silicon systems to achieve cognition as we know it.
So I'm the founder of Syntience, Inc. The company is focused entirely on one single problem, which is how to make computers understand human languages. And we have a theory, soup to nuts theory, if you will, for how understanding and learning works. And we've been working on it since 2001. And we were very happy to see in 2012 that deep learning came along and basically showed that deep neural networks, which is what we use also, can do the most important piece that's missing in the AI toolkit today. That piece is called reduction. The reduction is briefly that you can take low-level sensory input, such as pixels from the retina and etc., and you can from that derive the high-level representations. It's basically the understanding part of a story problem. How do you go from being given a story problem to writing down the equation? That part has been missing, and we basically think we know how to do that. And deep learning has basically shown that they can do that. So I like to emphasize the fact that deep learning and neural networks are a very different kind of AI than what we've been doing so far. It is this ability to do reduction basically means that we can start over from scratch, if you will. So I think of AI as a 4-year-old discipline. Basically, nothing we did, or almost nothing we did before 2012, which we called AI. We did a lot of good stuff, but it wasn't on the path to general intelligence. And AI has basically started from scratch in 2012. And now is where we're going to see a lot of action. That's the reason for all of these AI companies happening right now, is because we're doing it very differently.
So the question is, should we drop everything and work on AI? Well, 15 years ago, I did exactly that. So I guess that's my answer. So why do I think it's worth working on AGI? Well, first of all, I think that AGI is possible soon. I don't think it'll be decades, as most people seem to believe. I believe it's more measured in years rather than decades. And secondly, I believe it'll have a good outcome, because that's, of course, the other question one has to answer. Is it worth working on from a point of view of being able to achieve something useful, and is it going to have a good outcome? Now, the reason I believe both of these, that it's possible to do it soon and that it will have a good outcome, is that I have quite a different view of what a practical AGI needs. Different view, different to what most people on AI are working on. Most people, most of the effort today spent on AI is on narrow, static, dumb systems. And I specifically call them dumb because a system that doesn't learn from its mistakes, a system that cannot tell you how it came to some conclusion. A system that you cannot reason with is dumb. So the kind of systems I think we need to build are adaptive, self-learning. They really what AGI, the term AGI, should be reserved to. And it's with those kind of systems that you get a lot of the benefits for free. They don't suffer most of the problems that I mentioned, for example, in the book Singularity. They don't inherently suffer the problems of value alignment and, well, the various problems. I won't go, in, we can go into a Q&A on that. So on the one hand, it doesn't suffer the risks and problems that are normally anticipated with conventional AI. And on the other hand, it gives us all the benefits that we're looking for technology that will help us conquer disease and aging. It'll help nanotech to really come to its own energy problems. We can solve abundance and ethics, most importantly, to help us come up with the right ways to govern ourselves and make sure we don't blow ourselves up and kill ourselves. So why aren't more people working on that? Well, I don't have time to go into that right now.
Well, it's kind of hard to add to all of these answers. I'm personally working at making AI smarter using optical computing. I think intelligence requires a lot of communication between different parts. And when you think of the only known like general intelligence, or the best example of general intelligence is the human brain. There's a massive amounts of communication. Optics is extremely good at communication. I think why work on it? I mean, I don't know. There's a suite of approaches.
Why are you working on it?
Well, it's a combination of that is very near term, as Peter's mentioning, and it has the potential to greatly affect the humanity's light cone. I think there was a poll earlier that 70% of people think that that we should value future human lives or future lives in general. Sorry.
That was artificial intelligence from a phone, not knowing that you were speaking.
And so if we're valuing future lives similarly, there's only 7 billion people or 8 billion people around right now. And there's the potential for hundreds of billions or trillions or 10 to the 100 to the 100, something like that. So I think the approaches like solving aging, which is what I was working on previously, very relevant for everyone alive today. But I think AI is potentially within our lifetimes and has the potential to affect more than just the people who are alive today.
So Peter, you brought up that the time frame that you think we're on to achieve artificial general intelligence is much shorter than most people think. I would love to hear what the panel thinks that term is. When is artificial general intelligence going to be here?
So AGI, means different things to different people. I believe that the kind of intelligence that's going to really radically change our society, it's happening now, and it's the next few years. When it can start writing good poetry, we don't know. There are kids taking classes in college and as class projects doing music composition systems, poetry systems, painting systems, and they're not as good as Van Gogh, but they're getting there. And so I think having a huge impact on humanity's view of itself and on society, we're talking very, very short time scale. The deeper realms of human consciousness and awareness, that I think is still an unknown.
I would wager inside of 20 years, we should be able to see a general purpose AI machine. But once again, I think it makes sense, bearing in mind that most of the terminals we interact with they're electronic, right? So if you look at your laptop or you look at your mobile phone, you punch in a lot of data in there. So when people talk about a general purpose intelligence, I often think not just in terms of is it able to speak a language? In that case, it's a little bit more constrained. Is it able to recognize a face? But can it stand beside me and understand the same sensory context I am in? Can it change its intelligence from time point 0 to time point 5 seconds from now? So can it essentially be another human being beside me? Can I speak to it, and is it aware of what I'm saying? I think that system is inherently biology. The reason why I think that is because if you look in the human brain, for instance, the connectivity that you find inside the human brain, the number of neurons you have inside the human brains, we're talking about more than 100 billion neurons, and each of these neurons is more similar to a computer than it is to a transistor. So it's not clear to me how the present systems, it's not clear to me how they scale. So you might have one massive general intelligence built out of silicon, but then you would need more than 8 billion people connecting to that or being able to do computation off of that. So I think inside of 20 years, with the combination of biology and silicon, that is perhaps possible.
So just on that point, Monica, I know you have thoughts on the timescale of AGI as well as the technology that's needed to do it. So along with the timescale, do we have the technology that we need now, or do we need to develop new technology to have this done in the timeframes that we're talking about?
In my opinion, we have the technology now, and to many people's surprise, even the regular von Neumann machine is the optimal architecture. We don't even need GPUs, in my opinion. I've done AI for about 30 years, and halfway through, around 2001, I basically had a religious conversion from one kind to the other, switching from the reductionist world model building to a holistic mind model building view. I mean, model the mind, don't model the world is my slogan. And there is this joke about if at first you don't succeed, lower your expectations. So in 2001, I switched from basically thinking about general AI in the way that everybody else was doing it because I saw an awful example of how it can't be done. And so I basically focused very hard on a very much simpler problem, if you will, which is understanding language. And that's the only thing we work on. Well, understanding language requires you know a little bit about the world, but starting from language understanding and moving outward, I think is the right thing to do. And since we already have all of the components that we need for this already exist, I think that we can get to language understanding machines rather quickly. It could be a matter of 3 to 5 years, who knows. And you know that you're there when you have what I call, what other people also call, a mixed initiative dialogue system, where not only is it a question answering system where you ask questions and the system answers you, but it will ask you for clarification and so on, and you can have a back and forth going. When you get that in your iPhone or Android device, as a Siri 4.0 or whatever, that's when you know that we have basically an AI that's capable of understanding language in a large chunk of the world. And we're going to get there very quickly.
Yes, I would generally agree with that we largely have the technology. Now, that doesn't mean to say that we may not need custom chips to scale up the system, to scale up a particular design. But by and large, I think there's not fundamental breakthrough in technology required to achieve human-level general intelligence. What I think is required, though, is for enough people, or some people, the right people, to work on AGI with the right model, with the right approach. Because, as I mentioned earlier, virtually nobody at the moment is working on that. Everybody is working on narrow AI, fixed systems that are trained with hand-picked data sets that don't learn as they go along, that don't interact really with the world. So you need systems that are inherently learning systems. And very few people are working on it. So it really depends on whether teams are going to start working on that with the right sufficient amount of funding. So when people ask me, when will human-level AGI arrive, I usually say, well, $100 million time, or whatever number you want to plug in there. So it really is a function of the right kind of research being funded.
I have to disagree that we have the hardware necessary. I think if you're...
Says the hardware maker.
Exactly. So if we want to compare, if we're looking at timelines for so AI is hardware and software. How much hardware do we need? We've got a software component, which is sort of a massive unknown. Hardware side, if we're comparing it to the brain, and we're comparing artificial neural nets versus biological neural nets, maybe there's a 1-to-1 comparison. Maybe it's like a 10-to-1, something like that. Maybe 10 artificial neurons equals 1 biological neuron, something like that. If you have that level of connectivity. The brain has 10,000 connections per neuron. Current computers have 3 connections, maybe 3. Like each transistor is connected to maybe 3 or 4, something like that. And yes, they go much faster, but there's still an awful lot of communication and computation gap between just the human brain and our largest artificial neural nets. Which
I think Ash has an opinion on how many artificial neurons make up a real neuron.
So one of the curious things is, so I've worked in my previous life on recurrent neural networks, and it's very curious that the explosion of artificial intelligence as we know it really took off hand in hand with the accessibility of immense computational power, which has been heralded by the Googles of this world, the Facebooks of this world, and the GPUs of this world. So we foresee a state where that will plateau. I mean, there is a space for the current artificial intelligence as we know it, but it will plateau. And I totally get the view from the computer science world where people think, oh, I can press a button on a machine and it can pretend to speak a language, and people are pretty excited about that. And it's really cool stuff, but it's nowhere close, not even close to what a dragonfly, considering the footprint it has, the flight it can master, it doesn't even come close. But I get the argument that because everything is on a computer and you can deal with it, I get that. And so I completely agree that the hardware, it's not even close. It's not even a conversation, in my view.
So I think one has to look at the view, though, as well, to say, well, how can aeroplanes fly? How many feathers do they have? How many cells do they have? I mean, we're not trying to reverse engineer a human brain, at least not with my approach. Yes, if we were trying to do that, I'd agree we are a long, long way away. But no, we are engineering an aeroplane. We're not reverse engineering a bird. So they're really very orders of magnitude different measurements that fit into it. And one particular approach that we are taking in our development work is, I call ours the Helen Hawking approach to AGI. So it's basically Helen Keller and Stephen Hawking with very low sense acuity and very low dexterity, so that we avoid a lot of the very computationally expensive stuff that needs to be done. But you can clearly have a perfectly intelligent brain that does not have good sense acuity and dexterity.
I couldn't, just to point to it, we, in our company, we hear this example a lot of when you're trying to engineer flight, you don't have to compare it with a bird. We hear it a lot. The thing is, flight, it's a transportation thing. It's not actually flight. You strap it on a rocket and you blast it and then it lands again. So a bird flight and an aeroplane flight, these are completely two different things, okay? But again, the AI we have as it is today, we believe the market value The way it can grow and what you can get out of it is immense. It's really incredible. But what we are talking about is cognition. Can you build a machine that is cognitive, that is aware of what it's doing? It's not a language machine, it's not a face recognition machine, but a cognitive machine.
Can I make a comment? So I think the example of autonomous vehicles is a really interesting one, because 10 years ago, DARPA had these contests where these autonomous vehicles would be in the desert, and they couldn't even stay on the road. They'd bump into rocks, they'd fall off. About 5 years ago, I live in Palo Alto, you started seeing Google's autonomous vehicles driving around the street. It's like, what? How is this happening? And it suddenly has become mainstream. All the car companies now realize that we're only going to need about 1/20th the cars we have today. So most of them are going out of business. So they're all in a to-the-death race to create the autonomous car. And NVIDIA, who makes chips, very fast GPU chips, everybody was using those for deep learning nets, and they said, oh my God, this is our next great niche. And so they started making special purpose chips for deep learning neural nets. And they now have a package that you stick in the trunk of your car that's specifically designed for self-driving vehicles, and it's almost become a commodity. And so I think that's the progression we're going to see in each of these areas.
So Peter, you brought up earlier that the thing limiting AGI is money. All we need is more money, and with that is you need people to train these systems. And I want to move beyond kind of the when question and talk about how, and talk about what obligation the people designing these systems and training these systems have when they're building them. I think we should start at the end, maybe, Michael.
So what obligation do people have?
If we're training machines to be making decisions, right, and they're relying on input that we're giving it,
yeah,
what obligations do we have with that input?
Yeah, so one of the previous Twitter questions was, what's your biggest fear? And most people said AI. We're all working on AI. I think that we have a tremendous amount of responsibility because of the range of effect that AI can have. If you're building an earth mover or a 6-axis robotic arm that's putting pieces in a car, it has a radius of 30 feet. If you're building AI, it has a radius of more than 30 feet, like maybe more than 100 miles, more than 1,000 miles. It's the whole Earth and the future light cone of Earth. So the responsibility is immense. Yeah, I mean, I think a large portion of any group's budget should be at, like, I don't know, 10%. What are you guys? What do you guys estimate on what resources should go into safety? Yeah, I'd say we're something like 10%.
So my biggest fear is not getting AGI. I think humans we're managing ourselves rather poorly as technology improves. So I think we need better intelligence. And in terms of what percentage of budget should we spend on safety, or how should we handle that, I think it's really looking at it the wrong way. By building an effective AGI, a system that can think and reason better than we can, we are inherently improving our own morality, our own ethics, our own decision making. So I don't think it's a separate piece that you bolt on. It's inherent in building an effective, intelligent system that it will also improve everything.
Well, if we accept that the kind of AI we're doing in the near future, continuing the neural network approach, is radically different from whatever we've been done so far, we have to rethink all of these issues about testing and dangers and so on. I'll give a couple of examples. When we had the old kind of AI, where we imagined the AI was going to be this big, humongous computer program with millions of lines of code that knew everything about the world because we had entered all of this information about the world, that was the traditional kind of AI. And we said, hey, if we let this computer, once it works, gives a little bit of AI, why don't we let it inspect itself and fix all the bugs in it? And this is called recursive self-improvement, which Steve has been talking about a lot. I actually now think that this recursive self-improvement is a myth. Why do I believe that? Well, the new kind of AI that we're going to use going forward doesn't need millions of lines of code. The first big breakthroughs in this were 600 lines of code on top of a linear algebra package. And I've seen published AI reports with 68 lines of code. So the AIs we're working on are very small, very easy to make, in theory. Once we figure it out how we can do this, anybody in a garage with a laptop can do this. And where was I going? So the dangers have to be reevaluated. There's still going to be problems. There's still going to be lots of problems where we have to basically do QA on the AI to make sure that it works the way we intend to. But the chances of it like becoming a Skynet is like almost zero.
The AI as it exists today, seriously, it doesn't worry me so much. In the sense that I do not believe we're responsible for it naturally. But what worries me more is the bad actor. That's what worries me more. That you have a secondary or a malicious party gaining access to such systems and using it for their own purpose. But the AI itself, the code itself, it doesn't worry me at all. But going forward, in terms of when we do get the general purpose AI, aside from the traditional safeguards we will have within such a system, so that means you can essentially turn it off whenever you want. I think it's also important to give individuals the right to do whatever they wish with their own machine, not being in control of a corporation somewhere or of a third party. So if I give you a robot that is intelligent, and so it should be made in your own image, not according to the image of a secondary. Because I think when individuals have this, then it's you have less chances of somebody writing malicious code and putting it up there.
So I think the ethical issues are huge, and they're not the kind of thing you can just devote 10% of your resources to deal with. I think the entire society is going to have to decide, what are our values, what do we care about? Autonomous vehicles are a really good example. Imagine your autonomous car is following a truck. The truck drops some stuff on the freeway that you might crash into and kill the occupant of the car, or it can veer to the next lane where there's a motorcyclist and kill the motorcyclist. It has to make that decision. If a person does it, well, in the spur of the moment, you decided to do one or the other. For an autonomous vehicle, some programmer in Palo Alto wrote that code, and there's liability issues, there's ethical issues. Should you preference the person in the car to somebody outside the car? In fact, Volvo has said, we're going to make our autonomous vehicles always try and save the life of the occupant. You know, safety is their whole thing. Is that great? What about Hummer comes along and says, we design our car so that it cuts in front of other autonomous vehicles and it knows how they work and it does exactly the optimal thing, so we get you there first. Is that ethical? Do we like that as a society? There are a million of those kinds of issues that are going to have to be teased out.
So to that point, there's lots of talk of this, and I think most people's fears when they talk about AI is this idea that it could harm humanity, it could harm humans. Does it matter if an AI harms humans in a different way than humans harm humans?
Well, I mean, we're building these systems. I think we want to build them for the good of humanity. That's my preference. And I think we need an infrastructure which guarantees that, like you were saying, some rogue person can't build himself a little army of robots and use it to, say, extort a city. Here, I've got 1 million drones with explosives on them. If you don't give me, $1 million of Bitcoin, I'm going to blow up your city. That's the kind of thing we need to be able to prevent. And right now, we're nowhere near having that infrastructure.
Monica?
So the question of how you program your car to kill the motorcyclist or somebody else, this is known as a trolley problem. And trolley problems are these schematic things of these ethical things. Trolley problems are reductionist ethics. They are basically useless because in every situation where ethics comes into play, there's a million things that matter. So ethics had to be considered holistically. And the basis of being able to make any kind of ethical decision is, do you understand what's going on? So we need understanding machines. Once we have those, the ethics will come reasonably naturally. And just the attempts to do what we're doing now, well, to be true. The truth is that our self-driving cars mostly today, don't know how much because I'm not at Google anymore, but mostly they are still based on reductionist, all kind of AI principle to a large extent. All the decisions at high level about what to do beyond vision and so on are done using regular programming. So there we have still the handle to do that, but I say we shouldn't. We should have computers that understand what's going on and can make the right decision holistically.
Let me ask one really quick question before we get to the audience, and that is, I think we can just do this with a show of hands. Do you think artificial general intelligence will lead to a Skynet scenario where the machines come to kill us? Okay. Yeah.
I'd like to know if the panel considers that what we call human intelligence or mind is localized to the brain, or as I believe, generalized throughout the body. And if it is not localized to the brain, how does this affect construction of AGI?
I signed up to get frozen head only. Does it answer your question?
I think it's localized to the brain, for sure.
Mostly. I mean, there's stuff in the spinal cord or whatever, nothing that matters. All of the important stuff is in the brain.
I think the body is intelligent. The immune system is almost as complex as the brain, but I think most of that intelligence is about the body, not so much about the thoughts that we have.
Hi, I work at OpenAI, and so we do AI research. And I guess it's a twofold question. The problem isn't money. Like, there's an aggregate of scientists that are working on these problems across the world, so there is an open research community. I think the problem is like isolated pockets of research. So we have a bias towards openness, but all of the commercial companies are starting to try and publish papers and at least share aspects of what they're learning, even if they have sensitive commercial work. And so my question to you on the panel is, even though some of you are early stage companies, how can you inform the rest of the community about what you're doing? Because that's how you move this forward. You need the science to not happen in isolation, but be a global effort by many different parties trying different strategies.
So I couldn't agree more with you. For us, we just finished our first developer conference in August. You're right, there are a lot of IP issues that we'll rather avoid, but I think it's crucial, especially bearing in mind that what we're doing, it's a lot different from what most do. I think it's super crucial to maintain that open space, not just in terms of software development, but also in terms of open hardware that people, even as young as high school, have access to the tools we're developing. I couldn't agree more that there is enough money out there, but the skill set is a little bit, yeah.
So I love the idea of open science, but some of these systems are extremely powerful and potentially quite dangerous. Just a month ago, ISIS put a bomb on a commercial drone and killed 2 people and wounded 2 others. And so having totally open source free systems that are super, super powerful, you know, it's like, would you really want, say, nukes, the design of nukes to be open?
Sorry, I'll just clarify.
Yeah.
It's not like a dogmatic, everything must be open.
Yeah.
If you're working on radically different approaches to the rest of the community, can you expose a small aspect of that or the underlying thesis in a scientific way? So you don't give us the system, but everyone, you know, is working on stuff like deep learning. If you have something that you think is much better, can you somehow expose an aspect of that so the deep learning community can say, maybe we're wrong? You know, that's useful.
What I've done, all the theories I have about this are basically available online as videos. If you go look for my most important video, which is 20 minutes, it's called Dual Process Theory. If you find that video, you can just Google for it. You can watch the others on the same page. And that basically gives you most of the story in small packages. That's like 9 videos or something. I recorded these videos because I was running the Silicon Valley AI meetup for 5 years and 115 meetups. And we had a lot of cool people talking. But whenever I felt like it, I would give one of my talks, record it, and then made a video.
Yes, from my perspective, I've also published quite a few of my ideas. I basically think that most of the work that's done in AI and in open AI and so on, I think is inherently misguided towards AGI. I agree that it needs a cognitive architecture, and I think that is really the fundamental approach. And there are very few people who believe that that is the right way to go. But I I've published quite a few short pieces on that, nothing academic. So I'm very happy to discuss it. In fact, I'd welcome it.
So we haven't really considered how much to keep things open at Fathom. It's a difficult question, I think. As Steve mentioned, there's you don't want to release everything and you don't want to release nothing. I think we're somewhere in between there. We are a public benefit corporation, so we have an explicit open goal of benefiting all of humanity, and we're held accountable to that. So I'd love to engage with OpenAI actually to go over that. I mean, we're 5 people right now, so maybe in next year.
Yep, over here.
Speaking about cognitivity, will artificial intelligence have a gender, male, female?
How does
man and artificial intelligence, as far as I've seen it up to now, it's much more done by male than by female.
Yeah, I'd also push your shaking heads, push on your shaking heads a little bit. If the people who are training these systems and designing these systems are men, does that imbue a bias towards a masculine point of view into these systems?
Well, we have quite a mixed team, if that were to matter. But ultimately, when you get to human level AGI, the system will also be a good psychologist and a good actor, so it will be able to take on the appropriate persona for the occasion. But there's no reason to have an inherent gender bias in an AI, as far as I can see.
I'd just make a comment that Alexa, the Amazon system, is a female voice. Siri is a female voice. Google Now is a female voice.
But they're, despite being behind a female voice, doesn't mean that the logic that they use would be typically associated with women.
Yeah. But it is sort of curious, and many of the movies recently, like Her, and there's now Westworld, and everybody's watching that, and Humans. And all of those, the lead android character is a female.
So one good test for you to know if the AGI is good enough is that it has no gender.
So the systems I'm building, they are based on intuition, and we think of intuition as a female thing. Turns out that's actually not correct. Everybody uses intuition for almost everything. And guys, when they don't want to kind of recognize intuition as a valid thing, they come up with explanations afterwards. But I think that under the covers, we are all using intuition for almost everything we do. You don't need logical reasoning to make breakfast or drive your car or understand language or generate language or enjoy a symphony. These are all things that we do intuitively, 100% intuitively, 100% subconsciously, and that's where we have to start.
The litmus test is if it's correct, it's a woman, and if it's not, it's a man.
Yeah. I think it would be, I think male or female, I think it would be much more alien than that. So not much more alien.
Yeah, I have a question for you. This is, do you honestly believe that once we created a general AI that is as smart as a human, or maybe 10 times as smart as a human, that considers itself as an entity and as a life form, do you honestly really believe that it would allow us to switch it off?
The average lifespan of an AI in the next few years is going to be something like 50 milliseconds. The first uses of AI are going to be things like systems that understand language, that analyze web pages and stuff like that. We turn them on, we give them a web page to analyze, we turn them off. It's okay. It's okay.
I'm talking about the farthest future when we have a 10 times smart AI or even more than that, and that's not a 50 milliseconds. That's general AI actually.
So my problem is maybe it's just the way we think in this day and age. Why does it have to be your slave? I don't get it. Like it could, if you develop an AI to serve a function, it serves that function. You don't need to dominate the AI or whatever. It just does what it does. I don't think you have to program it to be a slave or otherwise. It's just.
But you are the one who said that we are in control to switch it off, and
So for me, when I say being able to switch it off, it's simply a point of If it goes rogue, for instance, it doesn't do the function it's supposed to do. I don't see the conflict. I don't see the conflict between us and AI. I don't know if I make sense to you. So if the AI goes completely rogue, sure, you can have a fail-safe in it, but it's my thinking that it doesn't have to be that relationship.
If we design an AI that doesn't have an off switch, we deserve what we get.
I want to get in one last question down here.
So back to the AI safety conversation. With the good old-fashioned AI, you had a rule set that would create an outcome. And if something went rogue, you could go back and trace out what went wrong. But with the deep learning, you have a statistical mess and very little ability to infer why the system made the decision that went rogue. So for each of you here, what are you building into the systems that you're designing so that you can inquire when something goes wrong, what reasoning the AI system used to make that decision?
And if we want everyone here, we got to go real fast. Go ahead. Monica.
So I'll start. So for me, that is the central question, that there has to be semantics that is explainable and that we can trust and believe, and that current systems generally don't give us that, so I think we need something more.
My answer is that we can't compare our AIs to other devices that we have because they're so radically different, especially if we're using neural networks. We have to compare them to human performance, and the way to basically get reliable AIs is to just test them a lot. And people who are worried about all these jobs are disappearing because AI is taking them over, they don't realize that they're going to be working on AI QA for the rest of their lives.
Yeah, my take on this is that this really comes back to fundamentally having the right approach to design. That a system is dumb if it can't explain its actions, and we need to design smart systems.
I mean, even though our system is inherently transparent, we don't have a good method of hardware implementation for safety, just inherently baked in. I think some of the points in concrete problems in AI safety outlined some good ideas. Having safety training sets, having one neural net examining another neural net to make it more understandable.
Yeah, that would be my approach as well. You could have AIs that examine AIs. I get where does that end? If an AI goes rogue, you should build in a self-destruct kind of thing into it. I would guess in the end. But I totally agree with you. When you look at deep learning codes today and you try to figure out what happened there, it's really, really difficult. But I think you should have an off switch in it. If the worst comes to the worst, then it shouldn't be your first resort. But I really doubt we get to a situation where AI is suddenly going to enslave us. It's not going to happen.
So I think, judging by these great questions, and I wanted to get as many of them, so we don't really have time for conclusions, but I wanted to thank the panel. This has been really great. I hope you guys all have a better understanding for all of this, and be sure to bring anything else you want to talk about to the panel the rest of the day.